Okay, where were we? Oh yeah, so there are independent APIs such as WASI, but we imagine that there'll be many such efforts in the future, and we want to be able to allow those folk to be able to specify their APIs in a way that promotes interoperability with other APIs. And then the final goal, which is to encourage the WebAssembly ecosystem itself to allow publishers and users to publish capabilities in the form of libraries that they can share and reuse. So on the other hand, we're not doing arbitrary programming language interoperability, although there is an element of programming language interoperability. We're not doing we're not solving the arbitrary problem, and in fact, it's reasonably straightforward to show that that's not actually possible to do. Nor are we taking any given programming language and saying that any library in that programming language can have its API expressed in this form. So if you're a Haskell programmer, for example, and you want to publish your API for other Haskell programmers, then you're probably not looking at the right place. Okay, so what's really involved? When one module talks to another module, what's the scenario that we're talking about? Well, I have code and I want to use your code, but I don't really trust you. So this can be characterized as an ownership boundary. So I'm using your code and I will give you what you need in order to get the job done, but it belongs, I'm not giving you anything more than that. And so what we do is we communicate not by sharing memory or by writing to a location, but I'm going to call a function in your library and you're going to give me back the results. And I'm going to give you in the function all of the data that you will have access to in order to do that. I won't give you a copy of my memory. I will give you the actual data, the actual information that you need in order to get the job done. I'm not going to give you a pointer to my memory. And the web API or the host API more generally is an example of the same kind of thing where the host doesn't trust me and I don't necessarily trust the host that much. And we still need to get our stuff done. So there are additional extras in the case of web APIs, but essentially the host embedding is a very similar kind of scenario to the module-to-module environment or setup. So if it's my code talking to your code, we have a kind of a way of talking about this, which is a form of linking but sharing nothing. So we call this shared nothing linking. Okay. Now, there are lots of other ways and standards and protocols for doing this kind of thing. One of the aspects that is different about interface types is that we're not basing this on serialization. Because we're in one process and there is no network connectivity necessarily, we don't actually need a serialization format. So semantically, the correct terminology for this is that we are going to coerce if I'm going to call your function, I'm going to coerce my values into something that you can understand. And then the result that you come back, I will reinterpret back in terms of what I understand. Okay, so there are ways of talking about this. One is, this is the wrong way around. One way is when I'm going from the level of WebAssembly to the level of interface types, then we call that lifting. It's lifting from the level of WebAssembly to the higher level interface type. And when we go from interface type down to WebAssembly or C++, that's lowering. And the combination of lifting and lowering is the coercion that I referred to. Okay, so the other main piece of this strategy is that each half of the partnership, if I'm a module, a client module calling a provider module, we both of us provide adapter functions. So if I'm calling you, I will provide an adapter function that mostly takes my WASM arguments and lifts them into WebAssembly. And if you're providing it, you will have another adapter function that does the opposite. So importing means I will adapt my WASM level code to the interface type. And if I'm exporting, I will be servicing a call, I'll be realizing a call that's expressed in terms of interface types, in terms of WebAssembly. And then what the host does, is we take these two adapter functions and fuse them together into a single function. So this is a kind of code generation approach. We take that fused code implements the glue between the two sides of the contract. If you were talking about WASM to WASM, then the resulting glue is just a pure WASM function. But if you were talking about invoking a host API, then this glue code lives somewhere in the middle of that world. So let's look at a small, simple example, a function that counts Unicodes. So I want to access a function that will count Unicodes in a string. The black text here is regular WASM assembler, and the pink text is special assembler for the interface types. So there's stuff that we haven't talked about here, but essentially within my WASM code, I will call this adapter function, and it does some special things, including, for example, going from a piece of memory to a string. So it interprets a block of memory and says, this bit of memory is really a string. Now I will call the function, the function expressed with an interface type signature called count codes, and then the result comes back with something I can use. In this instruction, memory to string, we're assuming that strings are represented as a pair of integer and length. We could have made other assumptions, but for the moment, and as an initial one, this is the one that we're going to go with. And one thing to note is that at the interface type level, we actually have a richer set of numbers than WebAssembly itself. So we have 8-bit numbers and 16-bit numbers and so on. The reason for doing this was to allow API designers to be be crisper about the kinds of data and the kinds of things that they're expecting. On the other hand, if I'm now in another WebAssembly module, for example, and I want to offer the count Unicode functionality, I also have to write another adapter function. This time, as I said, the task is to realize a function expressed in terms of interface types, and have to realize it in terms of WebAssembly. So again, there's a bunch of pink stuff here. And one of the things that I have to do is allocate space in my memory for the string that I'm going to count the Unicodes for. So that's what the call to malloc is doing. And then I do my various things, and then I call my internal function that actually does the work, and then I return the result. There's some details here which we can go into later on if we would like to, but I don't think we need to. So then we take these two bits of code and we put them together, automatically fuse those two pieces of code together, and we get something that's only black, i.e. it's only regular WebAssembly. And it does what you would expect. It copies from one memory space to another. copies the text of the string from one place to another, and then calls the internal function. Now, there's a small detail in here which is to do with managing memory. If you're managing memory yourself, it can get very hairy, especially if during the adaptation you have to find space for strings. So you also have to be able to release them, which is what this final deferred code is for. Okay. So that's a small taste of the kinds of things that you can do. We have designs. We haven't specified it fully yet, but we have sketched out a design for numbers, for strings, for calling functions and function callbacks, for handling sequences, for handling arrays, for handling records, for handling tuples, and for handling arbitrary data, algebraic data types. And also for things which have an interface attached to them, i.e. an object. There are some things that we're not going to support. We don't have any intention to support. The biggest one of these is anything that has a cycle in it. So any kind of graph structure is not something that we're going to support shipping over the wire. And also, we are not handling any specific language. We're not settling on C or Haskell or standard ML. We in a sense it's a least common denominator of common language semantics. Okay, at this point I'd like to hand over to Adam, and he will tell you about the WebIDL part of this story.
So yeah, Francis hinted at this a couple times, talking about, web APIs are sort of like this intermodule case. But since this is BlinkOn, we decided we'd also focus a little bit more on that case. So how does this relate to WebIDL? That's what the APIs we would like to be able to access using the system in the browser use. So to start with, one of the things about interface types is this language is very similar to WebIDL. In fact, a previous version of this proposal was called WebIDL bindings. And so it's actually like the types you saw on the previous slide. Some of those match up pretty closely with WebIDL. String obviously is a thing that's in there. One of the differences is, of course, that the website, the API side is a little bit more fixed than it was in this example with count codes. In Blink, it's generated C++ at build time. And that means that rather than doing that full fusion that we saw, we're actually going to create strings. So if you bring in a string, you're going to get a WTF string, for example. But even now, the examples we've seen, we're still talking at the WebIDL level, and let's get down into Blink a little bit and see how this works in the Blink bindings. And all this is very early, but just going through where we've gotten so far with the prototyping, our thoughts about how you link up into a web API. This is the basics of it. And as with the previous slide, we're going to skip over a lot of details about WebAssembly here, but WebAssembly is in modules. When you instantiate a module, you pass in its imports, and here we're passing in getElement by ID. So we're going to use that as an example as we move through. When the system sees that you're trying to call getElement by ID from WASM, it looks around to see if it has a binding stub for that, and checks the signature that you're using in your module to call getElement by ID. And if we find such a stub, then we're going to go through the path I'll talk about here. We also have a fallback to just calling it through JavaScript as you would today. That's both useful for the case when the module and the system disagree. And it's also something we may use if we decide not to generate WASM stubs for every single web API, which is maybe 10,000 things for binary size that may be untenable. So we might focus on ones where there's a big value to having low overhead calls. So now as we get into this implementation, we have some new concepts that we need to add, or augmentations of concepts we talked about previously. There's the module itself, which is this code, that we're shipping, that's coming off the web, author code. There's the import adapter, which is the code we're generating at module instantiation time. That's mostly the lifting side, as well as some additional code to know how to call the Blink stub that's being chosen here. There's the stub itself. This is the equivalent to what we have on the JavaScript side. It does the lowering, which for this case isn't exactly lowering into WASM, but lowering into Blink. And then that will call into the actual implementation itself. So these things are somewhat analogous to what we have in JavaScript, but there are differences to each. I'll go into those. So first, there's the same thing that we saw for count codes. There's the module talking about this getElementById function that it wants to call. So in this case, it's going to pass a string, and you also see this anyref parameter. One of the things that this proposal depends on is the ability to refer directly to host references from WASM. The rest of this looks relatively similar. We say we want to create a string out of memory, and then we're going to call this getElementById function. Again, the pink is the interface type specific concepts. Don't stare too closely at this, but today, if you called this, we would have to do things like check, well, how many arguments did you pass? The number of arguments is one of the things that's part of that signature in the previous slide. And so in JavaScript, we have to check for that. In WASM, we won't. Here's we are actually converting some JavaScript thing to a string in the WASM bindings, in the JavaScript bindings. In WASM bindings, we won't have to do that. So let's move on to the actual WASM side that we're here to see. And we'll focus on a few things. We saw anyref in that previous signature. And so we have to take that anyref and actually check that it is a document. We have some ideas about how to avoid that type check in the future, but that may involve further dependencies on the WASM side to be able to refer not just to things that are in the interface types space, but are types defined by WebIDL, like document, element, node. And here's the interesting bit for as far as lowering is us making copy from the WASM memory into a WTF stringer, and maybe creating an atomic string depending on what we decide to do in the implementation. And then at the end, we actually call into the getElementById method. So I talked a little about the differences, number of arguments, type checking, whether we know what kind of reference we have, how exceptions are handled. One of the interesting things for WebAssembly is that we can actually do overloading as part of that signature matching, because WebAssembly can say, I want to call this particular overload, whereas for JavaScript, that overloading always happens dynamically on the call. Also, as I mentioned, though right now we have some optimizations to check the JavaScript holder type for method calls. We definitely have ideas about how to make that just as fast, or maybe better, even more statically known for the WASM side. But today, that's going to be using runtime checking. Yeah, I think that's the end of this section. So I was going to hand back to Francis. I want to say also that I'm sort of standing in today for Bill Budge, who's been doing all of the sort of prototyping work in the engine to figure this stuff out. He couldn't be here today.
Thank you. So you've had a small taste. Let's see what the benefit of this is. The first, not in any special order though, but we expect that if you use interface types, then you will get a more consistent way of accessing web APIs that is not so JavaScript centric. Also, this is one of the keystones for being able to link WebAssembly modules together in a way that honors the semantics. So shared nothing linking is a little bit like Webpack today for JavaScript. We also think that allowing publishers to publish their APIs in a language neutral way will benefit both the publishers and the users of functionality. And because we haven't actually showed you very much of this, but the signatures are the type interface signatures are actually a separate document. They don't belong to either the provider or the client. And having it that way allows API management to work for WebAssembly as well as it does for other systems. So where are we? Well, the design, the design principles are done, and the design, a lot of the elements of the design are there for what we call a minimum awesome product. We have some toolchain support in the form of polyfill. So one of the merits of the WebAssembly approach is that we can have automatically generated polyfill as well as automatically generated glue code. We have some prototype APIs implemented in V8. We're focusing on web APIs and Canvas at the moment. And we're going to be realizing that behind a flag experimental soon. I can't be more precise than soon, though. All right, so thank you very much for listening. And are there any questions?
Get another mic.
So used strings as an example of something that's fairly simple to move across the boundary here. Within Chromium even, strings are very complicated. How do you deal with cases like strings where the representations in the two environments might not even be like compatible in a way that you can convert losslessly? For instance, web APIs tend to represent strings as a series of 16-bit code points, which may or may not be valid UTF-16. A lot of environments people might target with WASM might use 8-bit strings, which might be ASCII or UTF-8, and that might not be something that you can convert losslessly. How is that sort of thing expected to be handled?
Well, we have two parts to our response to that, and strings are known. We knew that strings were difficult. Go back to here. So in the memory to string example, right, that's where, so there's two halves to that. That's one half of things. So in the memory to string operation itself is embodied a particular assumption about how the string is laid out in memory. So we're starting with UTF-8, but if you had strings that were in WASM, this is on the WASM side, remember though, if you have a string that is a different encoding that we wanted to support in the standard, then we would have an additional instruction in here which would say, you know, funny thing to string, and that's generally where the semantics of the string representation are going to be embodied. And conversely, for the other way, for lowering, if you have a string to some UTF-16, for example, that would also be an operator going from the abstract string to UTF-16. What we did fix on was that a string abstractly is a sequence of Unicodes. We're not saying how the Unicode is represented, but it is a sequence of Unicodes. So
if invalid Unicode is passed, is this service as an exception?
That would be an exception. That would end up in a trap.
So if I, like, for instance, if I say like read the inner text of some DOM node, that can contain data that's not valid Unicode, because I can do that from
you could have you could have several operators, some that are sensitive to being valid and some that are not.
Okay, so this is sort of something that you might explore if it becomes a problem in practice?
Yes, it's an extensibility point in the design.
Okay.
but good question.
I just want to clarify my understanding that having interface types, I'm interested in WebIDL binding related stuff. Having interface types, we can eliminate conversion from JavaScript to Blink, right? So I mean, your example shows strings can directly convert it to the WASM to the Blink side. So that means we can eliminate some overhead converting string.
Right. So like today, if you made this call, you would have to first call into JavaScript and create a JavaScript string and then call into the binding. So in this case, the thing we're eliminating is the creation of the JS. We don't have to do any JS heap allocation to create the string.
So is it the same for other primitive types like numbers or?
Yeah. So one of the reasons we're excited about WebGL is because we think that for numbers are actually one of the easiest ones here, because we may be able to get very good type information that WASM even understands and pass those through without even any copying.
Mm-hmm. I see. Then, but the DOM object like Canvas itself could still we will use the JS object.
Yeah. So for this getElementById example, at the moment, the thing that it will actually return. I mean, at the end here, we're actually, well, maybe this isn't quite right because it's saying an element star. We will wrap that in for now, and maybe that's what push return is doing here. Mm-hmm. In the really long run, there's no technical reason why we couldn't be passing around oilpan objects in WASM. Like any ref doesn't say, like in WASM, that's talking about host references. It doesn't say that these are JavaScript objects. But for the near term, I would expect that for DOM objects, we will represent them as JS wrappers.
Thank you.
It's not serialized. Yes, it's getting passed back, and V8 knows is able to handle JS wrappers as any refs in WASM.
Yep. So the copy. So we're not doing an extra copy there to.
Right. There's not when this is doing a push return. That's just doing a wrap of the element and then putting that pointer in the return slot.
Yep. Okay. Thanks.
So you mentioned holding.
May I just follow up on something? Sorry. When within any ref, it's what you have is a foreign value inside the WASM, and WASM is and it doesn't interpret the foreign value. The only thing you can do is pass it to an argument going out.
The engine does interpret it and knows to trace it.
Speaking of tracing, this is another mechanism for calling between the JavaScript runtime or the WASM runtime and code that was originally written in a non-garbage collected language like C++ or something like that. We had that same sort of a similar environment for a long time in the browser, where we have C++ code that is managing objects that exist inside of the JavaScript heap. And we ended up suffering for a really long time with trying to do reference counting and various things to manage the lifetime of these objects, so that you didn't end up with GC cycles where each one holds roots for the other and neither of them knows that this can be collected. Is this a problem that we anticipate needing to solve for WASM, that we might need to trace references that go out to the JavaScript heap and back into the WASM application? Or do we think that the uses will be simple enough that they won't have the problems we have?
So at the moment, WASM does not have GC, and if you have an AnyRef, then what you're really saying is that this is something that the JavaScript heap should be garbage collecting.
But I mean, I think I would expand on this. That does mean that if you have logic in your WASM application that says that I need to keep this AnyRef alive, and if somehow you've exposed some JS stuff to the browser that is also keeping your C++ alive, then you could end up in the same situation. We are definitely thinking that's one of the reasons that we would like to get WASM-GC to be a thing, to expose more of what's going on in WASM to the engine and to the engine's GC. I don't have a good way of judging how likely it is that we'll end up in that situation. That's a question that definitely Hannes and his team have asked us a lot of, like, how are we going to manage that? We are managing this in a totally different context using JS weak refs to at least allow you, when you're exposing JS APIs from WASM, to do some do the same things we were doing in Blink, basically, where we had weak pointers and got callbacks when something died. For those cycles, I don't have an answer about how likely that is. We're running over, so maybe we should wrap up. But if there's one last thing.
Well, thank you.
Yeah, thanks.
Thank you for